Today we're going to talk about the volume of common shapes that you'll see in geometry. We're going to talk about what volume is, what it means necessarily to find the volume, and how to go about finding the volume. So before we even start with dealing with problems and explaining how to find the volume of a shape, let's take a little recap into area. So the best way I like to describe area is finding what's on the inside of a two-dimensional shape. When I say 2D, I just mean we're seeing a little face of a shape here. We're trying to find what's on the inside. Two-dimensional, doesn't go into any depth like what you see in real life. So when we dealt with this, let's say we had a square here, a 3 by 3 square. To find this area on the inside, we had to take a side and basically carry it throughout the entire shape. And the way you carry it throughout the entire shape is by multiplying by the side length. And you would see this commonly expressed as maybe something like length times width. However, I'd like you to think about it as base times height. It's just another way of saying these words, but it makes a little more sense when you're talking about it in terms of volume. So you can call 3 here the base and 3 here the height. Call this one the base, this one the height. So we draw this as a rectangle too. Let's say we have a 2 by 4 rectangle. You could either call 4 the base or 2 the base. It just depends which one you want to pick, and then the other one would be the height. So now, keeping that in mind, we can apply what we know of the area into finding the volume of some common shapes. So let's just pull up a couple of variety ones here that we can look at and see how, although they're different in a lot of aspects, they're also very similar. So first, we're going to deal with a rectangular prism. So we have a rectangle. It goes into 3D, so we call it a rectangular prism. And we're going to give it some dimensions here. So we're going to say this side length on the bottom here is 6. This side length here is 2. And this side length looks about, let's say, 3. So with that in mind, we have to find the base and the height. And that's why I said let's talk about area in terms of base and height instead of length and width. So what we're going to do is, just like in area, how you have a shape and you have a side length and you're multiplying it throughout the shape to find the area, we're going to do the same thing when it comes to volume. So we're going to find a base first, whatever base you want to pick, and we'll look at both of them. And you're going to find a height that you want to multiply it by to find everything on the inside. So let's say, to start, we wanted to pick this as our base, this bottom rectangular bit. Well, we know the equation of a rectangle that we can take 6 here times 2 to find that bottom rectangle. Okay, so we say 6 times 2, which equals 12, and we'll call that the base. But at the same time, we could say that this face could be our base instead if we wanted to pick that. And either way is fine. In this case, it doesn't really matter. But we would just say 3 times 2 equals 6, and that's the base. Now, depending where you want to start, the base will determine which height you'll be multiplying by. So we saw that, let's look at the red base. If we have this as the base, this little rectangle at the bottom here, then we're going to have to multiply it to fill up this entire shape. Because you want to find all that inside area, so you're going to take the face, or the base in this case, and multiply it by the length that goes throughout the shape to fill on the inside. So we can see that the base here was 12, and that if we want to multiply it throughout this entire shape, we have to multiply it by this line right here, which is 3, because that brings you all the way throughout to the top. So we can take the base, which is 12, times 3, which is the height, and that gives us 36, which is the volume. And since we're talking in terms of 3D, because it's volume now, we're going to say units cubed. Now, I'm saying units because we haven't specified anything, but it could be centimeters cubed, inches cubed, feet cubed. Doesn't necessarily matter. Your teacher might give you specific units. Just make sure to put some sort of unit on it at the end of the day. Now, if we're going to pick green as the base, we're going to be multiplying, well, filling up throughout this way of the shape. And that's because we have the base here, and we need to go all the way throughout the shape. What we can see is this line here. Since this line is 6, we also know that this is 6 up here. So we found that 6 would be the base in the green case, times 6, which is this length that goes all throughout the shape. We'll call that the height. And this will come out to 36 as well, and that's units cubed. And now an important detail is that no matter which way you go about finding the volume of the shape, it should be the same no matter what. And that's just because everything has a set area, a set volume at the end of the day. You can't have a cup that's 1,000 milliliters, and then if you go a different way, it's 500 milliliters. It just doesn't necessarily make sense. There's only one volume for everything, just like 2D, there's only one correct area for the shape you're finding. So rectangular prisms are interesting because you can go about it in more than one way. Now when we work with some more complicated shapes that we only have one set of tools to find, there's basically only one correct way to go about it. So let's say we have a trapezoidal prism. We have a trapezoid 3D, makes a prism, trapezoidal prism, with the following dimensions. Let's say this bottom here is 5. This top is 4. And then we're going to have, let's see, a height here of maybe 2. And then this side over here, let's just say it's 3. Okay, so we know that when it comes to a trapezoid, you got base 1 plus base 2 all over 2 times the height. And that's why I give a lot of dimensions in this one, so we can find the area of that trapezoid and then bring it all throughout. So before we even work on this, let's kind of demonstrate what we're going for here. We're going to find this area of this trapezoid to start with. And that to fill up this entire prism, we got to multiply in this direction to fill it up. So first step, we want to find that base, which, because we picked this trapezoid to be the base, we know it's going to be the area of this trapezoid. We can use the equation that we know. Base 1, we'll say that's 5. Base 2 is 4, divided by 2, times a height of 2. So that's going to give us 9 over 2 times 2, which is equal to 9. Okay, now we know that we have the base of 9, and we want to multiply it throughout this direction of the shape, shown by the arrows. And the side length that follows that direction is 3 right here. You can see that's going the same way as those green arrows. So we're going to say that the height is 3. So we have our equation of base times height, and that's equal to the volume of the shape. We said that the base was 9. I find the area of our trapezoid base. And we know that the height, the side length that goes in the direction we want to go, is 3. Multiply those two together, you get 27. We're going to say units cubed, just because we didn't pick any specific unit. But this goes to show that if you try to go about it a different way, you're not going to quite get that same answer. Because you could try to maybe find this side length over here, if you had this side. And then you could find the area of this rectangle here. But if you tried to multiply it throughout, you realize you're kind of multiplying at this whole slant, and you're not really going to fill in the shape. So it gets a little confusing, but you'll know in examples like this that when you're giving a trapezoid, you're probably going to be finding the area of that trapezoid and bringing it throughout the entire shape. Rectangular prism, we're working all 90 degrees here. It doesn't really matter because it's going to go throughout the shape regardless. So we're going to look at some more examples here. We're going to work with a triangular prism. So a triangle that's in 3D, which is a triangular prism. We're going to give it some side lengths here. So let's say this is 3 right here, and that it has a height of, let's say, 3.5. Looks about right. And then we're going to give a side length of 4 right here. So what we're going to do in this is talk about what we want to make our base, so then we can find which height is appropriate. Since we know we're dealing with triangles here and it goes all the way throughout, making this triangle shape, we're going to say that the base is this triangle face right here. And we'll start by finding that base. We know that the equation for a triangle is base times height, all divided by 2. We have the base right here, which is 3, times the height, which is 3.5, all over 2. And this is equal to 10.5 over 2, which is 5.25 for the base. Okay, now we have that, we want to see which direction we need to go in to fill the shape. So you can see that we need to go all throughout this way to make it filled in 3D. And the side length that is corresponding to that would be this 4 right here. So we'll say the height is equal to 4. Okay, now we have our equation, base times height equals volume. Base is 5.25. We said the height is 4, that's stated. 5.25 times 4 would be 21. No specific units, so we'll say units, then cubed. Okay, so that's done with the triangular prism. Let's go on to the cylinder. So this isn't a circular prism, it just has a special name called a cylinder. Okay, so let's act like this is a perfect circle. Definitely isn't, but it has a center point right here, like any circle does. And I'll draw one along the side, just to kind of show that. So this is the bottom that we're looking at. We'll draw this side by side, just so you can see how it looks in 2D versus 3D. And this is going to have a radius of 3. And a radius goes from that center point all the way to the edge of the circle, and it's the same in every single direction because it's a perfect circle. And then, with that in mind, we're also going to have a height of, let's say, 10. Now we're going to say centimeters here. Just get some practice with units and seeing units. So we know that our equation is base times height equals volume. And now what do we want to start with as the base? Now if you try to pick any side of this cylinder, you're going to realize you're running into some troubles, and that's not so easy. You're going to find the circumference and multiply, and it's going to get very weird for the volume. So rather, what we're going to do, we're going to pick the base to be this bottom circle. We'll act like that's a perfect circle, just like the top is a perfect circle. I'll reiterate that these are the same thing at the top and bottom because it's a prism. It carries out perfectly. So we'll pick that as our base. We're going to find the base quick, and then we'll multiply it by the appropriate height, which we'll see what that is. So the base here is that circle, and we know the area of a circle is pi times radius squared. Okay, pi is the number, 3.14, and so on. Radius we said was given to be 3. I'll put that in red just to show that's where it came from. And we're going to square that. Okay, so we're going to have 9 pi as the base area. So you could say centimeters squared as the base area if you wanted to. And we know that we have to multiply the base by the height to find the volume. And we'll see here that in order to fill up the shape, we're going to go from the base to the top. We're going in this direction. And if you look what side it goes in that direction, it's this one right here, which is 10 centimeters long. So we have the base, which is 9 pi. We're going to multiply that by the height, which we are given is 10, which means we have a volume of 90 pi centimeters cubed. And you can multiply 90 by pi if you want a specific number, but we'll keep it in terms of pi right now, just to keep it simple. Now the last 3D shape I wanted to talk about and finding its volume is a sphere, and that's only because it doesn't really follow any of the things that we previously talked about, and it has its own equation. And I compare this to finding the area of a square or rectangle to find the area of a circle. You know, you can't really apply any of the rules of area to circle, and it just has its own equation that you just have to memorize. And when it comes to the sphere, that's the same case, unfortunately. So I'll give the little equation here for volume of the sphere. we're going to have 4 over 3 times pi radius cubed. So this looks a lot like the area formula, which is pi times radius squared, but it's going to be slightly different just because we're going in 3 dimensions here. Okay, so when it comes to a sphere, it's going to be the same distance all around no matter where you start. You're going to have your center point. You go out this way, that way. If you go out to this edge or that edge, we have the same radius going all along, the same diameter going all along, and you're going to have the same circumference going all along. So just like a sphere, just like a circle, it doesn't matter as long as you're starting that center point. It's going to be the same length all over. So let's say, just for this sake, we were given the distance here from the center point to an edge. And we were given that the radius is 4. That's all the information you need to find the volume. So if you can remember the equation, that's truly what matters, and then you just have to plug it in and find the answer. So we have 4 over 3 times pi radius cubed, which is equal to 4 over 3 pi. We're given that the radius here is 4, so we'll say 4, and then cubed. Okay, let's plug that in and calculate it out. We're going to have 4 over 3 times pi. 4 cubed is 64. And to simplify that, 64 times 4 is 256 all over 3 pi. And we weren't given a specific unit, so we'll just say units cubed. So all those shapes in total kind of give the idea of what it is to find volume. It's a little complex at first, just like area is confusing when you're starting, but the more you practice with it, the more you'll understand. I'd recommend going through this video again, watching these examples slowly, and just understanding what all these arrows that I'm drawing mean, what it means to fill in a shape in a direction, just like it's to fill in the area of a direction. I'd specifically say remember to have units cubed at the end, or whatever unit you're working in, just like for this cylinder we had centimeters. Otherwise, beyond that, these are mainly the kind of shapes you'll see. Prisms are very popular. Cylinders are very popular for examples. But the sphere is its own kind of case down here. Maybe you're not working on spheres yet, but it's important to know, just like circle, all you need is radius in an equation to find out what the end result is. Beyond that, there's nothing more to volume, especially at this level. There's nothing to concern yourself with. So like the video, comment, share with your friends. Feel free to ask me any questions. I love to answer them, and I'll see you guys in the next video.